Let's look at problem 76 from Project Euler, counting summations. In this, we are given that it is possible to write 5 as a sum of exactly 5 in exactly 6 different ways. So 5 can be represented as 4 plus 1, 3 plus 2, and so on. And notice that the ordering does not matter in these summations. So 3 plus 2 is same as 2 plus 3, hence only the frequency of the number, how many times it is taken, that is of importance here. So they are asking us to count the number of different ways in which the number 100 can be written as sum of at least two positive integers. So we are asked to find out the number of ways in which 100 can be written in the same way they have mentioned the different ways. So let's go through in brief. So we need at least two positive integers to represent 100, and the ordering does not matter. Hence, we need to make sure that if we consider a number, let's say 10, two times, then we don't need to again consider it anytime. So either take it 0 times or multiple times. So this is the main idea. So let's go through the approach for this. So since we need to count the ways, we can think of a dynamic programming approach in which we know what is the current sum that we are calculated and what is the number that we want to insert, and we can iterate on the number of times we need to take that in the sum. So let's go with the dynamic programming approach. So the main observation is that the sets, if you represent 100 as a sum of 1 and 99, and the same set can be ordered differently, but it is counted only once. Hence, it is evident that we need to go over the numbers that we want to use as a summand. So let's say we want to use 1 in the summation of 100. So we need to only check 1 times that how many times then we need to include 1. Either it will be 0 time, it will be 1 time, 2 times, 3 times, depending on what is the sum that is left over. So the main approach is to try numbers from 1 to 100 one by one. So if we try 2, then we will try 3, 4, so on. And each time we have two choices. So either we don't take I in summand. So as we can see, if we started with 1, we didn't take 2, we didn't take 3, 4, and so on until 99. We took 99. So all the numbers between them were not chosen as a summand. So the first choice is to not take the number, or the second one is to take it at least 1 times, and this can be as many times as possible depending on whatever is left over. So we started with 1. We could have taken it 2 times, 3 times, 4 times, as many times as we want. We could have taken it 100 times as well. So that is the main option of going through all the possible choices. So to implement this, we need some information as a state. So first of all, we need to know what is the current sum that we are constructing. So if initially we are starting off with 0, and we are saying that start inserting numbers from 1, and if we take 1 5 times, then our current sum will become 5, and for the next iteration or the next recursive call, we are going to tell it that you need to start taking your choices from the number 2, and your current sum is 5, so that the ordering is independent. So this is the first information that we need to store in the state, and the second one is which number we want to use as a summand. So as we saw earlier, we were initially taking 1, then we went on to 2. Let's say we didn't take it as a summand. We said we don't want to take this as a choice and move to the next one, 2, 3, until we reach 99, and then we said that we want to use this number. Hence it was considered as one possible way entirely. So these two information are helpful. This second state will be incremented one by one based on what all choices use. So if we took a choice in one state, then for the next state that is going to be called after this, we'll have the number that we want to take incremented by 1. So that is the main idea. Let's also look over the recursive function, what it is going to look like. So let's say go is the function that we are going to call, and it is going to return us the answer for the number of ways to represent 100 as a sum of at least 2 or at least 1 positive integers. So this is the function that we are going to call, and the parameters represent as follows. So 0 represents the current sum that we have constructed until now. Initially it will be 0, and the numbers that we are going to insert it. So first of all, we are going to start with 1, and at each step we are going to have basically 2 choices. Let's look at the first one. First one is to don't take the number that we want to insert. If you don't take it, the current sum doesn't change, and for the next iteration we are saying that we didn't use this number, so try the next one. The next one is +1 of it, and this will branch out depending on it. Let's see the second choices. Second choice is to take this number at least 1 time. So if we can take it 1 time, 2 times, 3 times, 4 times, and depending on that our current sum will be changed. So if we take it 1 time, our current sum will be current sum plus that number, or twice, thrice, or let's say k times we have taken it. And again the next number that we want to try will be the +1 of the current number that we were trying. So this is the basic idea. We are going to add up all the ways because they are independent, and the total answer for this will be the sum of the 2 choices that we have considered, and this is the bound up to which we can check how many numbers that we want to take for this inserting number. So if we are going to iterate over this k from 1 to any times, let's say it might go up to 100 only, but we can say that this until and unless this condition is met, we are going to iterate over all the possible choices for that, and again the branches will go on, and we are going to eventually reach at a base condition. So let's see what the base condition may look like. Okay, so if the current sum is greater than 100, that means it is never possible to make it 100 because it is already went past 100, hence the number of ways will be 0 from there. If it reached 100, if it reached the value 100, then that means we have found one way to represent 100 as a sum of the numbers, and from there we can return 1. So these are the branches. Eventually they are going to converge some base conditions, so we are looking into that. And it might be possible that the current sum that we are having plus the number that we are inserting becomes greater than 100. So this case is also ensuring us that the sum will become greater than 100, and we can simply ignore that, or that there is no possible way from here to make it equals to 100. So these are the base conditions. I hope the logic is clear. Let's look at the C++ implementation for this. So I've declared the DP array for each of these states. We have the same function. We are going to call it, initializing the DP array with -1 to memorize the answers, and our go of 0, 1 is going to calculate all the ways, and we are essentially subtracting 1 from it because they have asked us to find 100 as a sum of at least 2 positive integers, but our solution is going to consider 100 as a sum of single term, which is 100 itself, hence we need to remove one case from there. So now let's look at the recursive function. So the base condition, as we discussed, if it is greater than equals to 100, we check that if it is 100, then there is one possible way. If it is not 100, then it returns 0, and if it is the number that we are inserting is greater than 100, there is no possible way from here as well, so it returns 0. Current is the current sum, and number to use is the number that we are trying at this state. This part is the memoization. If it is initialized with -1, then this code will be run and our answer will be stored here. But if it is not -1, this tilde sign represents that it boils down to the Boolean expression not equals to -1, then we can simply return the answer here, so that our time complexity is reduced. And again, C1 is the choice one to take it as many times as you want. So current plus k times the number we want to use is at most 100. After that after that it becomes greater than 100, then there is no possible way, so it is better to bound it by this expression. And we are going to store all the possible ways for choice one in C1, and the second one is to simply don't take this number any number of times, which will say that use the next number. So this will do it, and total number of ways will be sum of the both of the choices. And we can store our answer in this referenced variable, which is going to basically memorize the DP table. And yeah, this will give you the final result as well. Total time complexity for this is, this loop may run up to 100 times, because let's say current is 0 and number we use is 1, then this loop will run 100 times, saying that take 100 times and still it is less than equals to 100. Hence this loop will run at most 100 times, and these two states are going to take up 100 units of memory each. So space complexity is 100 times 100, and time complexity will be 100 cube, which is well within 10⁶, and this will run fairly fast, which will be less than 1 second. So yeah, this was the quick solution for this problem. I hope this was helpful, and do let me know if you have any doubts in the comment section.